Hello, and welcome to our webinar entitled Analyzing Data at Scale to Return to the New Normal Post-COVID-19. All participants are in listen-only mode. We do want to open this up for Q&A if there's time at the end, so please add your questions in the chat box at the bottom of the screen, and we'll take them at the end of the presentation. I'm Carol Gunst, Director of Marketing at AtScale, and it's my pleasure to introduce you to our speakers, Durench Yusal, Chief Technologist at Intelia, and Daniel Gray, Vice President of Solution Engineering at AtScale. They will explain how to leverage data analytics to return your company to the new normal after coping with COVID-19. We will also showcase the AtScale platform, highlighting significant query performance on big data sets and perform live multidimensional analysis on COVID-19 data using popular BI tools with the AtScale Cloud OLAP model. And now, let me turn it over to Durench and Daniel. Durench?
Thank you very much, Carol. Daniel, can you just go to the next slide for me? Brilliant. Awesome. Good morning, all. I'm really excited to be here today and give you some insight into why Intelia have partnered with AtScale and how we think that AtScale is changing the way organizations engage with and analyze their increasingly disparate data sources. So who are Intelia? For those of you who don't know, Intelia are a Melbourne headquartered data and intelligent automation consultancy. So we only do data. We kicked off our partnership with AtScale just over a year ago when we're looking at a tech partner who could help a lot of our clients unlock the value in their data, right? Most organizations we're talking to were really good at capturing and storing the data, but analyzing, understanding, and being able to effectively draw insights and reporting had always come up as a key issue. So right now we're living in a strange new world, right? With COVID having impacted almost every area of our lives. Most organizations are actively looking at ways to get back to work and are doing intensive planning, right? So resource planning, trying to understand what levers we have and what we need to push. Today, we'll touch on some resources your organizations can leverage to help you in your planning. And at Intelia, we're actually using these data sets ourselves in our resource and activity planning. In doing so, we'll demonstrate the power of AtScale and show you a bit of how it works and how you can effectively manage your own data. Specifically on AtScale, Intelia is implementing the first production deployment of AtScale in region, right? So in Australia. We're working with a major utilities organisation, and I'll touch on some of the problem areas they currently have and the way that AtScale is starting to help fix in the next slide. A final note about Intelia and what we do, right? So we do end-to-end data, from data strategy throughout to implementation, and one area that's going more and more important is data management and governance. Daniel, touch on the next slide for me. I'll quickly touch on the current implementation that Intelia is helping with and some of the key areas that I guess we're targeting, right? So the first area that our client had issues with was varying answers due to disparate data sources. They had their data in multiple databases. They had different definitions and business logic to report on. And one user building a report was getting a completely different answer to another user, even though they were asking what looked to be the same question. The second issue was around a lack of governance on where data is accessed, who can access what, and how this is all managed. And finally, and probably the most impactful area, was query performance, right? Querying significantly large data sets, we're talking millions to billions of rows of data, taking hours, if not days, right, to actually get an answer back. And AtScale has been able to almost immediately address this issue that they're having. With this, I'll hand over to Daniel to give you some insight into the AtScale platform, show you a live demo and how it all comes together, as well as finally highlight how you yourself can access the data sets that we'll be demoing today. Thanks, Daniel.
Thanks, Durench. All right, good morning. Thanks everybody for joining. So what I'll do is I'll spend just a couple minutes talking about the AtScale platform and what we do. And then I'd love to jump into the demonstration and actually show you the product, show you the data sets and some of the models that we're building to help people generate insights. So just to give you a high level on AtScale, there's really 4 main components. There's a lot of different capabilities in the platform. But essentially what AtScale does is it basically looks at the different query patterns that are coming in from different tools. It could be BI tools, it could be SQL tools, MDX tools. And we're basically understanding those patterns. We're using heuristics and some machine learning to automate the data engineering to, 1, get you the best possible performance on any multidimensional analysis that you're running, and 2, to reduce costs. So basically reduce the amount of I/O and compute that we use. And we call that autonomous data engineering. And the way you can think about that is right now is if you think about the human capital that you have tied up in building structures and summaries and aggregates and constantly maintaining them and constantly trying to understand how to create new ones and anticipate new workloads, we simply automate all that through AtScale platform. Another key capability of AtScale is the universal semantic layer. So I'm sure a lot of you are familiar with semantic models or semantic layers. They've been around for a long time. What's unique about AtScale is that we're truly universal. So this means that we support more than a single BI tool. We support the different tools that folks are using out there. So we support the Power BIs and the Excels and the Tableaus, and we have a SQL endpoint, and we have an MDX endpoint. The important thing there is that gives you the ability to define all your business constructs in a single place. And what I mean by that is the ability to define things like quantitative values. So number of patients, sales tax, different quantitative values that you want defined in one single place and reuse across your different analytics tools. And I'll come back to governance in a second, but this basically ensures that, each one of these tools are getting back the same answers, and you don't have to go back and debug and figure out, well, why is Excel returning a different value than Tableau, and so on and so forth. In addition, in the universal semantic layer, you can start to define row level security, object level security, and additional security that would be basically inherited across the different BI tools. And again, it goes back to a computer theorem. Define once, so define your business constructs one time, so including dimensions and hierarchies, and reuse them versus redeveloping them and re-engineering them in all your different data platforms and in your different tools. So I hit a little bit on control of cost and complexity. And so this is really about AtScale's ability to anticipate workloads and automatically do the data engineering to ensure that you get that performance that Durench was referencing earlier. And also to ensure that you're reducing, basically I/O and compute. So the cloud is great. It's elastic. You can do a lot of great things in the cloud. But if you're not careful, you can run up a bill. What AtScale does by ensuring that you have the data engineering done for you is to basically ensure that you have a predictable cost model. So as you add new use cases to the cloud, you're not going to see a linear cost increase. And the last thing is really around mitigation of risk around data and analytics. And so that really goes back to, if you are defining all your business logic in one single place, then it's unlikely that you're going to be taking risk by either redefining it in different locations and different silos, getting different answers, and then being able to apply things like row level security and object level security in one single place. So that's the core capabilities of the AtScale platform. There's a lot of kind of tactical capabilities that we have, and I'll try to show you that during the demonstration, and would love any questions that you have after we wrap up. So just one more architecture slide here. If you think about AtScale and where we fit into the cloud stack, we're essentially, the way to think about it is that we're an abstraction layer between your consumers and your producers. And so if you look here, AtScale sitting between the BI tools, the machine learning tools, different applications that are using APIs, and your back-end systems, so your data warehouses, your file systems, your data lakes. And by putting this abstraction in there, you start to get things like self-service, you get agility, you get the ability that the BI or the business group can work without spending all day on the phone, speaking to someone about, how do I join this or that? And can you build this aggregate for me? And how do I find this data asset? We basically eliminate all those problems, and we give the flexibility to the business to be able to just go out, use the tool that they want, do the analysis they want. And it also benefits the data platform teams because you can start to make changes. If you move data from one platform, so let's just say that you're on premise on a traditional relational database, and you start to move that data to the cloud, so you're using some type of cloud data warehouse, AtScale is going to allow you to do that without any impact to the business. And so it gives the flexibility of IT to make changes. You can go from normalized to denormalized. You can make any changes you want. The end user it's completely transparent. So you get business continuity. So that's the best way to think about AtScale, is that we're that abstraction. We decouple the business or your analytics community from your back-end IT platforms.
That's a really important point, right?
Yep.
So speaking to Chris and the wider AtScale team, a lot of organizations are looking to move a lot of their on-premise data assets into the cloud, whether it's a cloud data warehouse or a new data warehouse. Implementing AtScale in between the business and the back-end tech almost allows you to do that seamlessly.
Yes, that's a great point, Grinch. One of our customers, Home Depot, they were actually on Cloudera, and they were moving to Google BigQuery. And since they had AtScale in place in the universal semantic model, they were able to move the data assets over to Google BigQuery, basically republish the model, which only takes a couple seconds, basically go through and train the model. And then when they basically did this over the weekend, when their users came in on Monday and then logged in, they were basically pointing at Google BigQuery instead of Cloudera. So we were able to completely forklift all their store managers that use Excel over to Google BigQuery without any type of business interruption. All right, so let's jump into, I promised only 2 more slides and we're gonna get into the demonstration here. But we just wanted to point out a couple things about OLAP. So, traditional OLAP cubes do have baggage. And, as new platforms have come out, we have more elasticity, we have big data platforms. There was a concept that, hey, we don't need OLAP cubes anymore because we have these really fast columnar systems and MPP and elasticity that we can just throw all the hardware and CPU at computation, and we don't need to worry about any type of pre-aggregations and things like that. It's understandable because there's a lot of negative baggage that comes with traditional cubes. You have to build them, you have to maintain them. There's scalability issues, there's data movement, there's pre-aggregation. And if you change something, if you change the hierarchy, you got to go back and rebuild it all. So it's understandable that type of scenarios has some negative consequences that comes with it. AtScale is different. So we provide an OLAP capability. So that's multidimensional analysis against cloud data warehouses or frankly, any type of data warehouse, giving you the ability to connect live with Excel, with Power BI, with any different tools without any of those negative consequences. So that means that we don't pre-aggregate data. We will not take data off your back-end platforms, put it somewhere else, pre-aggregate it, make it just right. What we actually use is that autonomous data engineering, and we'll actually do that on the compute that you already have. So you don't have all the negative baggage of, do you have to build something? Do you have to maintain it? Preventing people from making changes. In other words, you have a new data set come in and you want to build a new hierarchy. Well, you don't really want to do that because now I got to change the cube and I got to rebuild the cube. AtScale is a virtual cube is the best way to think about it. And so we don't have any of that negative baggage that comes with traditional cubes. But more importantly is that multidimensional is not going anywhere. That's how people run their business. And so AtScale gives you the flexibility of continuing to do multidimensional analysis directly into any cloud data warehouse using MDX or SQL without any of the kind of the old school cube builds. And so that's what AtScale does. AtScale gives you that cloud OLAP capability without traditional cube technology. All right, so that's the last of the slides. So let's see if we can get into the demo here. What I'm going to do is escape here. All right, so the first thing I wanted to do is talk a little bit about the data sets and what drove us to build some of the COVID data sets and publish models. So as you guys are all aware, there's a bunch of COVID data sets out there. You can Google them. There's a million dashboards. They all look the same. There's Johns Hopkins. There's WHO. There's quite a few different data sets that are out there. And if you go out to Snowflake partnered up with a company called Star Schema. They made a bunch of data assets available, and folks could then go in and start to consume those data assets if you have a Snowflake account. Well, we went out and we looked at those data assets. And if you look over here on the left-hand side, this is basically the Snowflake portal. You'll see a bunch of the different tables that they expose, and they've added stuff over time. But you can see stuff from the COVID. So this is the COVID tracking API. This is the Johns Hopkins, the JHUs here. This is Kaiser, and so on and so forth. So there's a bunch of different data sets out here. But what we started doing is we started looking at that data, and it's great that it's been exposed so people can analyze it. But you need some skills to do that. And I've written SQL for a long time, so I don't have any problem necessarily with that. But if you're an analyst, if you want to be able to log in with Tableau, with Power BI, with Excel, and you don't want to spend a lot of time writing joins, do I do a right join here, or a left join, or an outer join, or what happens if I have an unrelated dimension, or what happens if it's cumulative in nature? So in other words, if you look at the rows in the Johns Hopkins data, you can't just go do a select all cases, sum up all cases for Afghanistan, because if you do that, the numbers are going to be wildly wrong. You actually have to write a SQL analytic function to basically do last value, and then you got to partition over the right things and order by the right things. And again, it's not necessarily rocket science, but if you get it wrong, you're going to get invalid data. And frankly, it also prevents a lot of people that don't necessarily want to go in and write a bunch of SQL and spend hours trying to figure out how to join things and build different types of measures. It eliminates the ability to be able to consume that data for those users. And so what we thought about when we saw this data is, wouldn't it be great if we could just expose models that people could just log in with Tableau, with Excel and Power BI, and they don't have to write any SQL. They can just immediately start to go do analysis and hopefully find some insights that are important to them. And so what part of that process is exactly what AtScale was built for. So you can basically eliminate and abstract away the complexities of everything going on here in the data platform for your end consumers, just like we talked about earlier with the abstraction. So let's do this. Let's jump over. And here's a bunch of the SQL I was writing as I was going through, just doing analysis, trying to understand the data before I decided, hey, let's just go ahead and model this. So if I jump over here, let's jump into AtScale. So kind of your first view of AtScale here. So this is basically a model that we built in AtScale. And, so if you look right here, here's the Johns Hopkins data set. You also have the WHO and all those different data sets that we told you about. And we've gone out and we've built some really nice date dimensions and geography dimensions, because typically as you look at these data, where they're relatable is typically on the date and the geography. And then we started to build things like what we call degenerate dimensions. So these are basically dimensional values that are inside of a fact table that we want to make look like a dimension to an end consumer without writing any ETL. So we can do that directly here in the semantic model. So when someone logs in and they take a look at this COVID-19 Robert Koch Institute distinct type for German counties, that data actually shows up as a dimension in the BI tool, even though it's really embedded in a fact table in the backend system. So again, the end user doesn't need to know about the complexities of the data. And we built all this out, and then we exposed it. And so if you go take a look, this is what we call preview mode here. So when you log in as a consumer of this tool, consumer of this model, what you see is your dimensions. So your who's, your what's, your when's, and your how's. You see your hierarchies, so your drill down, so you can start to do drill down analysis. And you see your quantitative values. So you can immediately go off and start doing analysis. You don't need to pick up the phone and ask, how do I join this to that? And can you write me this gnarly SQL statement that needs to join 15 different things? You just have this and you go to work. And so before I get in to show you how we consume this in a BI tool, the one thing I wanted to point out is that we started off with all these COVID data sets over here on the right-hand side. And they're interesting as you get into them. They're interesting. And when you start to combine them, it's like you can start to look at things like, why is the WHO reporting differently than Johns Hopkins? But at the end of the day, if you go out and Google COVID numbers, you'll see the same dashboards everywhere using the same numbers. So it's interesting data, but it's aggregated at a pretty high level, and it's not correlated with other things that are going on in the world. So economic data, mobility data, all kinds, rental data, jobs data. It's not, those data sets aren't correlated. So if you want to take the COVID data and stop really focusing on the COVID analysis and start thinking more about the business side of things. So when will we get back to a normal? What will the new normal look like? How will this impact my business? We thought that was really important because that's how we work with our customers. And what we wanted to do is start adding new data sets. So not only can you go out there and look at like the Johns Hopkins data sets, but now you can start to do correlations. So you can start to go over here and look at Basically, so some economic data that we have out there. You can start to go look at the open table data. So who's going back to restaurants? You can look at TSA data. A lot of this is US based. There's a lot of global data here too. But the point is that you can start to pull a lot of these data sets together. So you can start to pull Google data and Apple data. And now as an end user, you can start to do all types of analysis and you never had to write a line of SQL. So it gives you that capability. So what I'll do here is basically show you really quickly how we expose this to the end users. In that traditional cubing world that we talked about, if I wanted to build a cube, I would hit a build button here and I'd go home for the night, or I'd go grab some coffee or something and come back and I'd cross my fingers and I hope that no one makes any changes. And by the way, before I publish this, one last thing is that within AtScale, these data sets can actually live in different places. So you could have like the Apple data sitting in Snowflake. You could have some of the COVID data sitting in Redshift. You could have some data sitting in Google BigQuery. You could have some data sitting in SQL Server on-premise. It's completely shielded from your consumers. You do it all right here within the semantic model. So with that, let's jump over and actually publish this model. So I'm gonna get this and this. Quickly show you how quickly you can actually publish a model in AtScale. So 1, 2, 3, done. That model is now available for consumption. So imagine for a second, tomorrow you find a new data asset. You either bring it in externally or you find it internally. You quickly model it out. You add your hierarchies, your dimensions, your measures. You hit publish. And it's available immediately. The moment the users start consuming it, that's when our machine learning and our heuristics kick in and say, hey, can we build data structures to make this fast and to reduce costs in cloud? And then you can come down and you can actually consume this model. These are the different tools that I have set up in my environment. But at the end of the day, we support JDBC and ODBC. It's kind of table stakes, what you expect. We support SQL and MDX. So this is pretty important because if you try to take MDX tools like Excel or MicroStrategy or Power BI to the cloud, and it's not necessarily a Microsoft product, you're likely not going to be able to use MDX. So you have to convert to SQL. So you lose the multidimensional capability and you end up doing extracts. With AtScale, just take your tools and go directly to the cloud. You can connect live with MDX and start doing your analysis. And it doesn't matter the data size. And I'll walk you through how we're able to do that in a second. All right, so that's the AtScale model. So we've walked through a little bit of the producer persona. So that's people producing data sets in Snowflake, making them available. You have a modeler persona, which has built the model. And now we've actually published that model, and so you can consume it. So what I'll do is I'm just going to go through a couple of different tools here. Our goal hasn't been to necessarily develop the insights. Our company, we're experts at data engineering and, automating data engineering and bringing these data assets together. What we wanted to do was expose this. So anybody can actually come in and register and get access to this data set immediately. And you can plug whatever tool you want in. We're really looking for the community to go out and develop insights themselves. So I do have some dashboards and stuff like that I'll show you. But again, our goal is really make this data accessible to anybody out there. So just quickly jumping in, I'm just going to bring up Tableau first. So the first thing to kind of point out here is that if you look at Tableau and you log in, basically what we do is we'll provide you a TDS file that you just double click and open. It's not a TDE, so there's no extract. But what you see over here on the left-hand side is exactly that semantic model that I showed you a second ago. So from an end user perspective, I never need to go into data source down here. I don't need to pick up the phone and call anybody and say, how do I join this or that? Or why did you change a foreign key? I just log in and I see my semantic model and I'm ready to go do whatever work I need to do. And you can see over here on the left-hand side, this is a pretty rich model. So there's a bunch of different COVID data sets, but we started adding Apple data. We're in the process of adding a bunch of new data sets as we speak. But we're starting to add a lot of economic data. You have demographic data. Population data. We're adding, some other GDP type of data right now, but you can also see travel data. The point is that you have everything here in one place that you can just go slice and dice, and you don't have to worry about the complexity of bringing that data together. What I will say is a lot of what I'm about to show you right now is probably things that you've seen in the past. And so when we first built this model, you could actually go out and do, some things that a lot of people have already done, which is go out and basically look at things based on geo and look at, kind of more mortality rates and cases and things like that. But once you have these new data sets, you can actually start doing things that are more interesting. So you can start to take a look at, kind of, time relative over, or time period over, a period of time. And so what AtScale allows you to do is define things that we call calculations. So within the AtScale semantic model, you can actually define a time period analysis. So and imagine if you wanted to compare a date today, a value today, sales today, to the same exact day last year, you can actually build that right into a measure that you can just drag and drop so that you don't have to write any complex code in the BI tools. And so you can start to see things. So if you look kind of from a high level, you can see the cases continue to increase. But if you really start to drill down, really, as everybody's aware, things are decreasing, over time, and you can start to get a breakdown of those different types of cases. You can start to take a look at mobility data. So you can see, kind of different trends of, this is workplace versus, obviously people are right now not taking transit systems and not going to work. Residential stayed pretty flat. But the point here is that you can start to do a lot of different trending. You can start to bring in the Apple data. So Apple's starting to show you, driving by transit, by walking, then you can break that down by geography. And there's just a ton of different analysis that you can do, and you never have to worry about any of the complexity or the performance. And I'll come back to that here in a second. And I just got a couple more things to show you guys, and we'll be able to open it up for questions. I'm going to go ahead and bring up this, Power BI here. So again, on your right-hand side, you can see the entire semantic model. So you didn't need to do any data engineering, nor did you need to redefine any of the business constructs. I was able to log in. It all just shows up. I can start to do analysis immediately without ever picking up the phone. Same thing with Excel. So this is Excel pointing to that same model. I don't need to even install anything. So no ODC drivers here or anything. All I got to do is basically connect in and provide the MDX endpoint URL, and I'm able to connect in. And again, if you look on the right-hand side here, you see the entire semantic model. So this gives you the ability to have that define it once and reuse it, so that you're not at the end of the quarter trying to figure out why Excel is returning a different value than Power BI and Tableau. You're basically defining all those in one single place. And again, so you can start to do the analysis. The very last thing I'll just quickly show you is that as you look at these data sets and as these data sets grow, it's important that you're not scanning a ton of data. One, because performance obviously is going to be impacted, but two, it's also going to increase your cost. So as you add new use cases in the cloud, you're going to see that cost just grow linearly with new use cases. Well, what AtScale does is basically, as we were talking about a little bit earlier, is that we're basically automating the data engineering required for the best possible performance. And so as queries come in from the different BI tools, we're looking at the query patterns and we're trying to understand, one, is there already a structure out there that will answer this question very quickly? And then two, if there is or isn't, is there something that we can build that's even better than what we had? And our goal isn't to build structures for every single query because that wouldn't be scalable. We're constantly looking at how we can avoid joins, how we can bring data together. If you're virtualizing data assets, so maybe you have some data in a SQL server on premise and some data in the cloud, we're actually automatically data engineering those together to eliminate the distributed join. And so, part of that is the autonomous data engineering, and it's our machine learning that's built into the product to kind of predict where you're going to go next. And so, for example, these queries that are coming in here, so this is an MDX query that came in, pretty straightforward. We basically send it through our cost-based optimizer. Snowflake doesn't support MDX. So in that case, you'd have to take Excel and maybe connect it with SQL or something, and you lose a lot of the capabilities of Excel. We will translate that, in this case, in Snowflake, into SQL. And what we actually see here is that we're not even hitting raw data. We're actually hitting an at-scale structure that we've automatically built that basically will go through, and it only required 210 rows versus millions of rows to scan. And we did that completely through automation. So there was no human involved whatsoever. We built those structures out ahead of time. And so that, from an end-to-end standpoint, what AtScale allows you to do is really decouple your consumers from your producers. It allows your solution to be agile. So bring your own BI tool, self-service capabilities. And then ultimately, we obfuscate out a lot of the complexity on the back-end platform. And then we automate all the data engineering to ensure you get the best possible performance at the lowest possible cost to compute and I/O.
Daniel, that point you raised multiple times and just showed, I guess, a bit of insight into what AtScale is doing. I think that is absolutely critical, right? So your consumer doesn't have to care about where the data's sitting or try and understand how to interrogate that data, right? It can sit in Snowflake, it can sit in BigQuery, it can sit in Cloudera, right? It can sit wherever it wants, but all they care about is writing the queries in the consumer tool, and AtScale takes care of the translation, whether it's NoSQL, whether it's Hive, whether it's SQL directly to the backend. AtScale takes care of that complexity for you.
Yeah, that is spot on. So there's a series, there's quite a few SQL engines that we support. And so, part of that is being able to bring those data sets together within that multidimensional model. And then the other half of it is the autonomous data engineering. And so, if you think about traditional federation tools, they really specialize in distributed queries. So you throw a bunch of infrastructure, a bunch of cache at the problem, and then hopefully you can do a distributed query really fast. We did not set out to build another distributed query engine. What we did is we use our autonomous data engineering to automatically data engineer that data together. And there's a lot of nuance in that and how that works. But essentially what we do is we avoid the distributed join. So yeah, it doesn't matter where the data sits. And if one day you have data sitting in SQL Server on premise or Teradata on premise, and you pick up that data and you move it to Google BigQuery or Redshift, you make that change in the model, you publish the model, and your end users have no idea that they're now pulling data from a different system. And so it's completely transparent to them. All right, so I think what I'll do is, Carol, maybe I'll turn this back over to you. I don't know if we want to open it up for any questions.
Sure, let's move it to the Q&A slide, and yeah, we'll take it from there. So we've had a couple questions come in. I'll ask the question of Daniel, and then I'll ask the question of Durench. What size organizations does AtScale work with, Daniel?
Yeah, so we have many customers in the Fortune 50. So we have large customers, we have startup customers, but many of our customers are in the Fortune 50s. And a lot of it has to do with, kind of where we started as a product, which is, accelerating OLAP capabilities on top of Hadoop. And as we've kind of transformed over the years now to also support the cloud platforms, this has really allowed us to partner with some of the largest organizations. So, companies from like Home Depot, to Bowl.com, to the Wells Fargo. And so we have some very large customers, and we also have a lot of OEM type of customers that are actually building applications and products directly on AtScale.
Okay, great. Durench, you want to take the same question? What size organizations does Intelia work with?
So we work with large enterprise in Australia, so ASX 100. The point around data rows is really, really critical. So the current implementation we're looking at has AtScale sitting on top of a data set that's billions of rows large, and the organization is looking to grow that with a significant amount of IoT data that's going to take that billions into trillions very, very quickly. Right, so the query performance aspect and the intelligent aggregation that Daniel just took you through is absolutely critical. So yeah, the larger the data, I think the better the value proposition of AtScale.
Okay, great. I'll open this up to either one of you who want to answer it. Sandeep asks, can you talk about the use case when AtScale was or can be used as a data source in the context of AI or ML, machine learning, and any associated best practices and guidelines?
Yeah, absolutely. So, where we started was really around the focus on business intelligence tools. And so natively, that's where a lot of our customers really get the most value out of AtScale, is by using something like a Tableau or Excel or a Power BI. But as I mentioned earlier, we do support SQL. And so there's nothing to prevent you from, let me see if I can actually just pull something up live here real quick, from actually just doing machine learning to a certain extent. So the thing to think about with AtScale is that we're really multidimensional in nature. And so when you're training a data set, typically you're going to do that on fine-grained data. But if you think about how in machine learning in general, a lot of the work that you do is you know, feature engineering, if you will, and that's what-if analysis. And when you're doing your what-if analysis, if everybody's operating on the same quantitative value, so in other words, if you don't have one person working in Jupyter that's redefined a quantitative value and another person doing another, and suddenly they get the wrong results because they have different features or their features are defined differently, AtScale eliminates those problems. So it gives you, you know, basically a universal kind of definition of the different features. And then you can actually just go right through and do your what-if analysis directly within a Jupyter Notebook session. And then once you've figured out your features, then you're going to go through and actually train your model. So to answer your question is where AtScale fits in there, it's really in two places. One is that we allow you to do, you know, really fast governed feature engineering. And then two, the feedback loop. So when you do learn something, you can then take that data and you can put it right back into the model and then turn that into dashboard reports that your BI community can then take and make that machine learning output actionable through like prescriptive type of analytics.
Great. Maybe I'll open this one up to Drench. What's a typical journey for an AtScale implementation?
That's a really good question, Carol. And I guess the way we're addressing in our current implementation is to kind of build out that universal semantic layer, business unit by business unit. So the end goal is to have a complete data catalog that's accessible by the entire organization in one place, clearly defined, that's accessible for everyone, right? The way we're going about building that data catalog is taking reports from each business unit and building them into that catalog. So it's almost like building specific reports, getting that uploaded and defined in the semantic layer, and then moving across to the next business unit, while training up that business unit and the users on how to directly interrogate and also manage their AtScale area to ensure that they continuously update that, right? So it's almost like, you know, taking off bits of a pie, and the aim is by the end of it, you've got the full pie completely accessible to the wider enterprise.
Great. Paul, who asked the first question, asked another question too. Could you give some examples of real life performance improvements that clients have been seeing?
So I'll answer that one, Dan, and I'll throw over to you.
Go ahead, Drench. No, go ahead. Yeah, thanks.
So the specific example that we're dealing with right now, a use case that our client was querying took, I think, 2 hours and 40 odd minutes in their traditional data stack. Throwing AtScale in between the users and the consumers brought that 2.5 hour query down to 3 seconds through the use of those intelligent aggregates. So it is absolutely significant.
And I would add that, so that's the performance side of it. And it's intuitive from the standpoint that you're just reducing IO and compute. And so I actually have a demonstration on a 100 terabyte data set where if I'm running against the raw data, queries take, you know, minutes to some queries take an hour. When I actually point at AtScale, those queries run in seconds because we're hitting acceleration structures that we build, which are around 24,000 rows versus doing scans of large amounts of data. We actually have quite a few different benchmarks that we've actually published around Snowflake, Redshift, and Google BigQuery with AtScale. So you can, we can certainly provide access to those. And then one additional metric to add is also the cost reduction. So we've had customers on different types of cloud platforms that are paying, you know, dollars for queries. So they, you know, could be paying up to $10 or $12 for queries. When they put AtScale in place, we've driven that down to, you know, basically pennies per query. So you get the performance impact by reducing the IO and compute, but you also get the cost savings.
And that's really important, Daniel, as more organizations shift to platforms like BigQuery and Snowflake, where you're charged for the amount of data that you're actually scanning.
Great. Hey, Daniel, I'll throw you another one from James. How do you deal with data security as a cloud service? for example, financial services or health data?
Yeah, that's a great question. So there's a couple different components. Just generally speaking, AtScale doesn't store any data, so we're not pulling it off the system. So if you have PII information, if you have a certain requirement that you're trying to meet and you're making the changes to the underlying data, we're going to pick up those changes. And so the first thing is that we don't store any data in AtScale. The second thing is that we inherit basically your security posture. And so whatever frameworks that you happen to be using, we can connect to most enterprise frameworks. And for the most part, if the platforms support it, we'll also do things like impersonation and delegation. And that means that if you define, RBAC type of policies within your platform, we're going to inherit those policies through things like impersonation. But fundamentally, what you won't ever see AtScale doing is actually pulling data off your backend platforms and storing it on separate infrastructure somewhere else. And so whatever rules, whatever requirements that you have on your underlying data, whenever you make those changes or enforce those rules, we're going to pick up those changes with any of the acceleration structures that we build on your platforms.
Okay, great. Drench, I'll throw you this one. Is data cached within the AtScale temporary structures, or does it hit the data warehouse or data lake? And is this approach dependent on the raw data not changing frequently?
I'll give it a crack, Daniel, and then I'll hand over for some AtScale specific product knowledge. So there's almost 3 layers to caching or performance acceleration, right? The first one being the aggregates that AtScale creates in the backend data sources. So if you're data sitting in BigQuery or Snowflake or SQL Server, the aggregates actually get created and live on those backend data sources. So the performance directly comes from those aggregates being created. The second layer is in the AtScale. It used to be called cache, Daniel. I think it's changed now. And that is the live cache in the AtScale platform that accelerates those even more by storing some temporary data within that cache. Daniel, I'll hand over to you for the AtScale response.
Yeah, no, that was spot on. And so it's always interesting to talk about caching. So we do have cache within AtScale. So there's memory on the system and we'll use it intelligently. So for example, exact query cache type of queries, or if there's like a small dimension, maybe we'll pin that in memory. So we'll intelligently use the memory that you provide us. But the big value is the acceleration structures that we build. And as Drench said, we actually store those in your backend platforms. Unlike cache, which is indeterministic. So it's kind of like cross your fingers and hope that it's there. Or, if you're asking a different question, it's not going to be there. Our acceleration structures are deterministic. And so our goal is to always have one there. And so we're looking at the query plans and we're analyzing what people are looking at, and we're kind of predicting, hey, you know what? You're looking at these 3 measures by these different intersections. I'm willing to bet based on what you've done in the past that you're going to be looking at these things next. And so we're always trying to stay out in front. And so we're deterministic in nature. So you get the acceleration structures that are there. They're materialized on the system. As you update the underlying data, you basically just tell us either through a scheduler, through an API, through a trigger. There's a bunch of different ways to do that. We'll automatically do all the hard work of updating those acceleration structures for you. And we can do incremental or batch. There's some nuance there. And then at that point, any updates that you've made are within our acceleration structures. And if you happen to ask the same exact question over, same question, or you have a small dimension that may fit within memory within AtScale, and we will cache that. But the big benefit is from those acceleration structures that we're building.
All right. Daniel, got another question for you. You mentioned data engineering is automated. Isn't data engineering required to keep the data clean and transform it into a structured format? Also, in cases where left joins are required for deriving metrics, do we need to do some kind of structural transformation before using that in AtScale? Any recommendations you can provide?
Yeah, that's a great set of. Yeah, no, that's a great set of questions. So let me run through that. So, and I may need you to go back to the first one there, but basically.
Oh, isn't data engineering required to keep data clean and transform it into a structured format?
Daniel may have fallen off.
Oh no. All right. Well,
No.
we'll come back to that question with Daniel. Durench, let me ask you, at Intelia, you have your choice with partners. What made you choose AtScale? Why is AtScale different from other platforms?
So I think there were two clear areas, right? One was the MDX support. The fact that you've got a semantic layer with direct MDX support for clients using, significant clients using Excel. It works out of the box. There are other solutions out there that propose a semantic layer, but the hierarchies, the metrics, and everything are kind of lost because you have to connect to it via SQL or extract the data out. That's the first one. The second point is around the intelligence in the background, right? So the aggregates and the creation of those aggregates, there's a lot of IP there. And Daniel mentioned a little bit around the machine learning and heuristics that go on to create those aggregates. But we've found that the AtScale platform is significantly smarter or better at creating those aggregates in the background. So they're the two key areas that we find AtScale over and above the other semantic layers.
Daniel, did you make it back? All right. Well, I'm sure you'll.
So hopefully this will work. So on the data engineering, so there was two parts to that. The first part was around data engineering. Yes, you absolutely do still need to do ETL, right? So you need to get the data onto the platform. The data engineering that we automate is really around the consumption of the data. So you still need data to flow into the system. You'll take that data and you'll get it into some form. It does not need to be normalized. And so you don't need to build out dimensions and hierarchies and everything else. It can be denormalized, and we'll actually take care of all the dimensionalizing of the data in the semantic model without the ETL. So you're absolutely spot on. You still need to do ETL. You still need to get the data into the platform. There's going to be some level of transformations for that. But once you have the data there, making it available and consumable to the BI community or the analytics community, that's where AtScale steps in. So one, we can eliminate the ETL to turn it into a dimensional model if it's not. And two, we'll do all the data engineering to make the queries that are coming in from the end users fast. But you're spot on that you still need to get the data onto the system. The second question I believe was around right or left joins.
That's right. In cases where left joins are required for deriving or derving metrics.
Yep. No, that's spot on. And the thing about it is that's like really relevant to the discussion around the COVID data, because the data is not all relatable. And so if you're not careful, you'll get invalid data. So in some cases, you may want to do a left join of the data. In some cases, you may want to do a right join. You may want to do an inner or an outer join, just depending on the type of behavior that you want from the system, especially around unrelated dimensions. And so what AtScale supports is really two main capabilities there. One is a semi-additive type of measure. And so if you had to go out and you had to look at something based on maybe a time dimension or a date dimension, and you wanted to grab a last value from a particular row, then you would use a semi-additive measure, and you can actually define that directly within AtScale. And then in addition to that, you can also handle unrelated dimensions directly within AtScale. So you can tell us what to do. You can tell us what should we do if there's data that's not in the left side of the join, or what should we do if there's data not in the right side of the join. Should we duplicate those data? Should we ignore that data? So that's all called unrelated dimensions, and you handle that all within the semantic model.
All right, we have another question. If AtScale's generating the queries for us, is there a way to customize or review them if needed?
You can certainly review them at any time. The customizing is more, we're looking at the heuristics, and that's what's impacting, the acceleration structures that we build and we use is all based on heuristics. So what's influencing that the most is the actual usage. But at any time in AtScale, you can actually go in and you can take a look at any particular query that's coming into the system at any time and actually see the different queries that come in. And you can take a look at them that are going through the system. So these are the queries that I was actually running with Excel a few minutes ago. So you can always go back and audit. You can see who's running what. You can see what different systems are hitting. And then you can actually see the outbound query that's actually going out to the backend data platform. and all the metrics associated with it too.
Okay, I'll ask this one of Dorench. When implementing AtScale within new organizations, what effort do you estimate for change management? And what's your focus when impacting people's roles or managing any potential job security concerns?
That's a great question, right? And it kind of comes back to the point that one of the key value propositions of the AtScale platform is to kind of minimize that data engineering effort, right? So teams that were required to be in the loop when an end user needed to build a report and engage with your technical teams to kind of build out the report, the dimensions and everything within that end data set is kind of less needed when you've got AtScale in between. So there's a couple of change management activities specifically that we help with. One is enabling the end users or the consumers to upskill in AtScale and understand how to use the tool and integrate with the tool. The second area is the data modeling team, who are the key creators of the models and the views within AtScale. And the third area is the data engineering team to support how AtScale actually connects into those data sets. And back to one of the earlier questions around how the data is structured, transformed, and kind of redified for AtScale to integrate into. Daniel, how are you finding that more generally across global clients?
Yeah, a big part of what, so I think you hit it on the head there. A big part of AtScale is around the autonomous data engineering. So if you think about all the human capital that is tied up in building structures, making things fast, you know, kind of working through debugging why people are getting the wrong responses, that's all work that we automate. And so you can take that human capital and actually go focus it on other areas. So typically with AtScale, it's usually not a very, you know, there's maybe a half a headcount that's managing the AtScale platform itself. And then you'll have a set of modelers that are actually building the models. And these folks can live in the business or they can live in IT. So you have that flexibility because you don't have that old school cube where you're kind of resisting anybody making changes. Here you can build different virtual cubes so anybody can make those changes. And then, you know, based on the query patterns, we're going to automate all that data engineering to make sure that things are performant and reducing cost. And so you're going to be able to take a bunch of the headcount that's kind of doing that day-to-day, you know, aggregate building and summary building, and be able to take those resources and use them in other areas.
Great. Another question here. Can AtScale integrate with data catalogs? Is metadata accessible?
Yeah, that's a great question. So we, yeah, so absolutely. So everything that you've seen today and, you know, mostly, you know, everything that you do around the operations of the platform can be done through our REST APIs. And, you know, so for example, I was working with a customer the other day that was integrating with Waterline. And so you can pull out our entire semantic model. The thing is that the great thing is that you'll want to do modeling within AtScale. So for example, if we go in and take a quick look at the model here, and I just jump into a particular dimension, so just bear with me one second. And I'll explain why I'm kind of taking this path in a second. If you model with an AtScale, we will actually make sure your model is valid. So if you look on the right-hand side here, this is our geo dimension. You see all these green flags? This is basically as you define different levels of aggregation. So if you're building a time hierarchy or product hierarchy or store hierarchy, so on and so forth, we will validate those are accurate so that you don't get the wrong results. So the power is to define the model here. And then once you define the model here, you can pull out every aspect of this model through our REST APIs. So you can get all the measures, you can get all the dimensions. If you look at a particular measure and we just jump in here, you can actually save information around the description of the measure. You can folderize the measure, and you can pull all that information out and then store it directly within your enterprise data catalog. So it could be something like a Calibra or Waterline or so on and so forth. And then people can be able to search for different, you know, those measures and dimensions and link back to this model. The last thing I'd say is that we also have a catalog capability within AtScale, which is really focused on the cubes. And so imagine if you wanted to go into AtScale and say, hey, who's defined sales tax for a particular region? Or who's defined this type of physical time hierarchy, physical year time hierarchy? You can then find that, you can request access to that particular cube so that you can actually participate in that cube. So we have a catalog capability but we can absolutely integrate with enterprise catalogs that are out there.
All right, another question here. Does the size of the underlying data affect the performance of AtScale?
So there is, you know, the amount of time it takes to build the structures is a function of the size of the data, but that is typically something that you do at the very beginning. And then you'll incrementally update or make adjustments to those acceleration structures. So there is some impact, of course, as you're building those original structures. But you know, fundamentally, after that, as your queries come in, you're avoiding the raw data altogether, and so you're hitting the smaller data sets. And so, as Durench mentioned earlier, a lot of our customers, you know, they have trillion-row data sets that they're using AtScale for. We're building the acceleration structures, and we're redirecting those queries that are coming in to hit those acceleration structures, those intelligent aggregates, versus going against the raw data.
Okay, great. And last question, and I'll let. Oh, did you have something?
Sorry, yeah, we missed one around the proof of concept. Is it common for clients to do an at-scale proof of concept? The reason I just want to touch on this is it's pretty much advised to do a proof of concept, right? So a lot of organizations that we're talking to are very keen on proof of concepts, not only to make sure that AtScale is going to address the concerns that they have, but also being able to see those performance improvements on their own data, right? So that is a really, really critical thing that we're saying kind of showcase the power of AtScale. So 100%, that would kind of be the first thing that we recommend for any of our clients.
Great. That was the last question I was going to ask tonight. So I just want to remind our viewers today that if you want to be able to test out the COVID-19 data sets that AtScale's put together, you can do that by going to AtScale, or you can email us at covid19@atscale.com, or you can go to atscale.com/COVID-19. And now I'll just turn it back over to Daniel or Durench and see if there's any last words you want to say as we wrap up our webinar today.
No, so I just want to thank everyone for your attendance. Feel free to reach out directly to myself or via the contact@intelia.com.au. Email if you've got any questions, want to have a chat, or want to get into a proof of concept with AtScale. Daniel, I'll hand over to you for any final comments.
Yeah, same thing here. Thanks for taking the time today. And if you're interested in looking at the COVID data, you want to be able to plug in one of your tools, just let us know. You'll see the URL up here. You can contact us and register and we'll get you set up. But otherwise, thanks for your time. And if you have any questions, please let us know.
All right. Thank you, everyone, for your time today. Bye-bye.